Since the Fukushima event just over a year ago, OPG has been very active, first confirming that our plants are safe, robust, and that there's defense in depth, but also looking at the lessons learned from Fukushima. And we've put in place over a dozen projects to make our plants even safer. We've brought in equipment, we've written procedures, we've done training, and improved our safety margins at both of our plants, Pickering and Darlington. At our plants, we can't have tsunamis, but we can have a lot of rainfall. And if the rainfall was more than we expected, we would want to have flood barriers in place to protect low-lying equipment. And that's what we've done. We put in flood barriers at our plants to make sure important safety equipment does not get disabled with excessive rainfall. One of the things you saw at Fukushima was hydrogen explosions. What we're doing here at all of our units is installing passive autocatalytic recombiners. These are devices that go into the units and would mitigate any hydrogen buildup and prevent an explosion, and they don't take power. At all nuclear plants, you have to be ready for a severe accident. This is an accident that goes well beyond our design basis, but you have to be ready for it. And so we've put in place a system called Severe Accident Management Guidelines, or SAMG. And what it is a set of procedures and a set of equipment that can be used if an accident happens that is much worse than expected. And we've done that at Pickering and Darlington, have procedures in the control room. The operators know what to do, they've been trained, and we're ready for that eventuality. What Fukushima really was a station blackout where all power was lost. And what we learned is we have to have another set of equipment that is diverse and flexible and can respond, basically ready for anything. So what we've done is purchased 12 diesel pumps. These diesel pumps can connect to water supplies from Lake Ontario and pump water into the steam generators at all of the units at Pickering and Darlington. They have onboard fuel, so the fuel lasts for 24 hours. They're also portable. They come on trucks, and the trucks can carry them to the site from high areas on the site, and the trucks actually have cranes on them, so if there's any debris in the way, the cranes come in, take the debris off, allow the truck to get to the location that we desire. And it's a flexible approach. It can be used wherever it's needed. One of the things you saw at Fukushima was a lot of concern over the spent fuel pools, what we call irradiated fuel bays. These diesel pumps can be used and are set up to add water to the irradiated fuel bays at Pickering and Darlington and keep the fuel cool. We wanted to get the equipment here and ready and available to the operator, so we've gone and done that. And we have procedures to allow the operators and maintainers to open up systems and install these connections. But in the future, we want to make that more simple. We want to make that a more permanent connection. So the next phase of this project is to look at all those connection points and make them quite easy, basically plug and play, where you can take this equipment and very rapidly plug it in and it'll provide cooling to the reactor. One of the other things you saw at Fukushima was the operators did not have monitoring in the control room. You'll recall them installing car batteries into the control room to provide power so they could see what was going on. What we've done is purchase 7 generators. These again are diesel generators with onboard fuel, and they will allow power to go to critical control room loads so that we can provide that monitoring to the operators. It's very important for operators to see what's going on, to monitor the system so that they know we're being effective. We are controlling the accident. All the people around the station, in the media, and the public want to know that we're in control. This provides the operators with that instrumentation so they can say, yes, we are keeping our reactor safe, or we need to do something more. So it's very important to provide that power to the instrumentation for the control room. To make sure all this equipment is usable for the operators, we first did tabletop discussions. We talked the procedures through with the operators to make sure that it did make sense, they could do what we were asking them to do. And we did that in March. What we've moved on beyond that to actually practicing. We've moved the equipment, we've simulated tying it in, and so that gives us an additional layer of confidence that we can deploy this equipment when it's needed. And we've learned a number of things by doing those exercises, and we'll continue to improve our procedures going forward. To make sure we're doing all the right things, we're very well connected with the international industry on this. We're connected to the US, to the IAEA, And we're monitoring those bodies closely to make sure that what we're doing is the right thing. And in fact, we're contributing to that discussion, and we're actually leading that discussion in many areas. Now, one of the things I want to make sure people realize is that our plants were safe. They were safe before and they're safe now. But what we learned from Fukushima is the installed equipment is not enough. The public needs to be able to hear us answer the question, what if? With this equipment that we've installed and our projects going forward, we're able to answer that question. We're ready for anything, and that's what we need to have in place after Fukushima. I really want to thank all the people who worked on Fukushima right at the time. We had about 80 people right after the event working on it. They did some excellent work, allowed us to present in public that OPG was moving forward, that we were active, we were learning, we weren't complacent. All those people have continued to work for the last year to put these systems in place, and we're very proud of what you've done, and I want to thank you very much for your efforts.